Welcome guys. So that's only 7, 9, 95 number of subarray bounding maximum. So given a nums and two integers left and right, and return number contiguous. So contiguous is so important that non-empty subarray such that the value of maximum element in the subarray left and right. So for example, 2, 1, 4, 3. So there are how many subarrays? Right? There are this one, this one, this one, this one, and this one, this one, and this one, right? And the maximum for this need to satisfy this region, right? So greater or equal to the left and then less or equal to the right. So obviously this 4 cannot happen, right? So anything contains these 4 will fail, right? So the result will be 2, 1, 1. So 2, 1, 2, and 3. So answer will be 3 of them. This guy, let's solve this. So 2, 9, 2, 5, 6. And the left is 2 and right is 8. Okay, so let's do this very quickly. So obviously that the simple observation is that now you go 9, right? So anything contains 9 it will be fails, right? Because 9 is greater than 8. So you can cut off this 9. And you'll see there is a 2, right? 2 is okay. So 1, and then this is 2, 5, 6. So these 3 are okay, right? So you start from, let's say this is your start, this is your end. And then your answer will be end minus start plus 1, right? Because this is a number of subarray that this guy counts. So it's right, so 2, 5, 6. Yeah, total you have 2, 5, 6, and yeah. So basically, sorry, it's not here, right? So you can get the 3 times 4 divided by 2. You're 6 of them. Okay. So 6 plus 1 is 7. Okay. So from here that you can easily write like the two pointer algorithm if you know this list. Okay. Right, so the simple idea is that let's say you go through an array. And then you initialize your start. Let's say you start from here. So start is something which you define to be the subarray star is star. Okay. And then their end is defined to be -1. Okay. Then you go through each of them. Okay. Okay, so the first condition is that let's say this is I. Okay, so the nums of I, there is a simple idea is that if the number of I less or equal to right, and the nums of I greater or equal to left, then you can just set let's say you can just set the end to be I. Okay, because the reason is that this guy already falls into this region. If it falls into region, then included it will not change anything, right? So if you set n to be here, then n can keep going, right? Because including this will not change anything. Okay, and the second situation is that the nums of I is greater than right. So this is a simple idea, right? If the nums of I is greater than right, that means what? That means these operations over these pointers over these guys so large, right? Anything contained will not be happen. So then you become a two different kind of subproblems, right? So you just set start to be I plus 1. Okay. Okay. And the third case is that if then third case is that nums of I less than right, then we just count, right? Let's say I initialize my answer to be 0. You just set answer plus equals to end minus start plus 1. The reason is that you are asking some start and some end, and these are all the array, or the number of array which satisfy this start from start, and yeah, this is the number of arrays. Okay, so this is algorithm. Yeah, just this, and basically I think this one is simple, this one is also simple, this one is you need to think a little bit. right? But you can stick around with this algorithm, and you will understand why this is true. That's it. See you guys next videos.